Hello guys, this is Tejashvi. Let me share you some content regarding a Databricks Lakehouse architecture. Firstly, I will brief you regarding a data warehouse architecture which supports only the structured data. So all the sources, operational databases, external sources, transactional databases will act as a source for the data warehouse, and we extract the data from sources and do some sort of cleaning, transformation, and some data preparation, and we load the data into the data warehouse, and it also stores some metadata. The metadata includes the information regarding a table schema and the location where it is located, and everything will be stored in the data warehouse, and this would be monitored and administered. And upon that we do have an OLAP servers which does the processing and supports the querying like DDL, DML, and all sort of some processing and analytics like things, the querying thing, and the output which is driven out of the processing will be accessed by the developers and brings the insights and analytics, data mining and reporting out of that. Pretty much this is a traditional way of data warehouse architecture which has been following from past like 20 years, like in 1980s and 1990s. And I would like to mention one important point regarding a data warehouse architecture is here the storage and the compute and the storage is coupled together, so we do not have the flexibility of bringing our own compute. So it's a proprietary model, it's not an open source model. So pretty much this is regarding a data warehouse architecture. Now let me explain you regarding data lake. So comes to the data lake architecture or data lake, I would tell it supports all the format of the data. It's a structured format, unstructured format, semi-structured format. So it ingests all the formats of data, and it supports in some sort of processing, distillation and insights. So some secure layer, it also supports the security features and some processing, and the upon the output we can perform data visualization, reporting and all the business needs. On high level, pretty much it supports all the formats and some processing and some security features, I would tell. And next, going on to Delta Lake architecture. It supports all the types of ingestions, probably batch processing, streaming ingestion, structured, unstructured, obviously, and all the data injection. It supports the Delta Lake. So here we do have a three quality layers, quality checks we can say. It's a bronze layer, silver layer and the gold layer. Whereas the bronze layer where we probably store the raw data inside it, and after some sort of transformation or cleaning or some sort of operations like merge upset which maintains the uniqueness of data, after some sort of cleaning we do stage the data in the silver layer. So and the final stage is the gold before making streaming analytics and before AI reporting stuff. We do stage the data on the gold layer, where in this layer probably we'll be doing a business level aggregates where we store the data in the gold layer. So it's probably an incremental improvement of quality of the data until the data is ready for the consumption. And I want to mention one more important point regarding a data delta lake is that so it supports an acid properties which is atomicity, consistency, and isolation, durability. um it's one of the good feature I would say, and it also supports the transaction log which stores the changes that happens to the delta tables, and whatever the changes we make and whatever the transactions, uh, everything gets stored into the transaction log. These are the main few features about the delta lake. Now going on to the lake house, actual our topic. Let me give a small comparison first. So data warehouse, so it's in a it supports only the structured data, and it's an OLAP, like most of the data warehouse is an OLAP databases, which supports the processing, querying, some SQL statements, and from there on we bring the insights and reports out of the processed data, I would tell. And coming to the data lake, it supports all type of data, unstructured, structured, and semi-structured, and it is compatible to do some sort of data preparation and validation before accessing the data for machine learning and data science. And it supports some of the data warehouse features but not more compatible for querying stuff, some database operations, I would say not more compatible for the database operations. But it is pretty much good for the storage. You can bring any cloud, it's a Azure, GCP, or AWS, any Azure data lake or something like that. uh, Coming to the lake house, so the data lake, upon that, uh, it's a delta lake which converts the unstructured format into the structured format through some binary conversion, I would tell. So from here on, like I would explain more briefly regarding our lake house. It's an unified platform, it's an open source, and it's more scalable even. So all the best features of data warehouse and all the best features of data lake, that means all the querying stuff, compute, and the storage from the data warehouse. And this supports all unstructured format. This is one of the good features. So all the good features would be supported in the data lake house. So probably it's build upon the data lake, and the top layer is a delta lake, and we also have, it's a delta lake, and we also have the unity catalog, which is an unified governance solution, uh, which acts as a single source of truth. So upon that we do the streaming and BI and data science and machine learning analytics. And I want to mention a few more points. Apart from, it's a unified platform obviously, and it's one of the good integration, it's a good integrator, I would say. It's a good storage, it's a good processing, and it's a good governance and sharing. And probably I have a one more slide which shows clear picture of a data lakehouse architecture. So the structured data or any format, so it's a whatever it is, semi-structured or unstructured, it supports a batch and streaming data and metadata caching, indexing layer, and data files in open format. So metadata APIs, which which stores all the metadata, manages all the metadata, and the SQL APIs, which is a data warehouse feature, and the declarative data frames APIs. It also supports a DLT, which is a Delta Live Tables. It's a building a pipelines using a Databricks. And finally, the BI reports, data science, data machine learning stuff. It's a one approach to how you work with a structured, unstructured data, and it also provides one end to other end view of data lineage. A data lineage meaning from where we are getting a data and where it is getting processed to where it is sent. It's this is called as lineage. So we will have a clear view on the lineage. um Pretty much, I would say it's a lakehouse is a simplified data solution. It's a simplified data solution, I would say, and with all the features, like instead of getting us, for example, say for Azure, we have a many services like Azure Data Lake, Databricks, and we do have a 5 to 10 I mean services. Instead of that, Databricks provides one unified platform for all the for storing, for computing, for the governance, for data sharing. I mean sharing the data more securely, I would tell. And it's more fault tolerant and scalable even. And um, and it's an automatic optimization. It supports an automatic optimization for the performance and the operations and for the storage purpose even. um, so I would tell, it is one good solution for a startup or global enterprise level businesses, or like any type of business, either it is large scale or medium scale or small scale business. This is one stop solution or one unified solution which supports everything. Thank you.